One last problem in linear programming, and then we'll call it quits. Each week, Mackenzie can make between 10 and 15 necklaces, 15 to 40 pairs of earrings. She earns a profit of $3 per pair of earrings, $5 per necklace. She plans to sell at least 30 pieces of jewelry. How many earrings and necklaces should she make to maximize her profit? So where do we start? Variables are going to be what? Okay, E and N. E represents number of earrings, and N represents number of necklaces. Okay, what's next? Yeah, so we start writing our system of constraints. She plans to sell at least 30 pieces of jewelry. We could start there. She's going to sell a certain number of earrings and a certain number of necklaces, and she wants that to be at least 30 pieces of jewelry. That one makes sense. That takes out that situation. We have more. Okay, so necklaces have to be between 10 and 25. How can I write that? Good. N is sandwiched somewhere between 10 and 25. N is greater than or equal to 10. N is less than or equal to 25. And that takes out the necklaces part. What else? 15 to 40 pairs of earrings, so I'm going to write okay, 15 is less than or equal to E is less than or equal to 40. Earrings has to be greater than 15. Earrings has to be less than or equal to 40. Any others? We took out this piece. Any more information here? The money part. So she earns a profit of $3 per pair of earrings and $5 per necklace, but what is it that we're trying to do in this problem? Maximize profit. It says maximize profit. So that is going to be what our objective function deals with. And we have profit sitting right here in this sentence. So profit of $3 per pair of earrings, $5 per pair of, or per necklace gives me my objective function. So what am I going to write for that? F of, we want to write these in alphabetical order. So E comma N equals $3E, $3 per pair of earrings, and plus $5 per necklace, so 5N. And that uses all of the information. So now we just have to graph this thing, which means we need to figure out where our origin is going to be and what our scale is going to be and which variable goes where. So, where's the origin? Lower left, because we can't have a negative number of things. And which variable goes on the x-axis? Earrings, because we labeled it that way over here. E comes first, so earrings. And that's number of earrings. And then number of necklaces over here. No, it doesn't matter. If you do it the other way, it makes no difference. But the reason that I want to put it that way is because I wrote E comma N in my function notation over here. And that leads me to X comma Y. And because I put E in the X spot, I'm putting earrings, E, on my X-axis. Okay? That's just so that I don't get confused down the road. Now when I write things down, I want to list the E coordinate first and then the N coordinate, so that when I plug stuff in, I don't get confused when I'm plugging in those coordinates and accidentally mix up which number goes where. Okay? So just be consistent. If you label it the other way, just be consistent the whole way through. Okay. Now what? Need a scale, and again, I've been trying to get you guys to use intercepts on your inequalities as a guide to get you your scale. Well, right away with necklaces, I know that I got to hit 25 necklaces. But here, if I cover up the E and I find my n-intercept, then I have to hit 30 there. So I got to get all the way to 30 on necklaces. I have 14 lines. What's a good scale? By fives is perfectly fine. So I'll mark some. Probably good enough. And now a scale for earrings. Again, use intercepts. I can see with this inequality right here that I have to get to at least 40. With this inequality here, if I find the n-intercept, I got to get to 30. So it seems like I got to get to at least 40. What's a good scale for my earring axis? By fives again is fine. And then mark it. All right, we have a scale. We know where our variables are. We're ready to graph. So go ahead and do that. And I will just make my lines magically appear perfectly straight. And I'll do it freehand. It'll be amazing. Feasible region, once we figure all that out, is right here. So now that I'm looking at this feasible region, I can see that I have 5 ordered pairs. This is a lot like the previous problem. I have 5 ordered pairs that I need to consider for my maximized profit. So I'm going to make my E comma N, and then 3E plus 5N, and my 3-column table. Now we just got to pick out all those vertices. I'm going to start right here because I know that one already. It is 15, comma, 25. So record that, 15, comma, 25. And again, make sure that you're recording those in the correct order. Okay, work my way around clockwise. What's this one? $40, comma, 25 is correct. Okay, and the next one, this one right here. 40, comma, 10, sounds good. And the next one, a little bit tougher because now we have the diagonal cutting through and we don't know for sure that we're right here. It does look like 20, comma, 10, but we can't guess. So what I'm going to do is I'm going to say, what generated this? What slope gave me that? Well, I have intercepts of 30 here. So if I go down 30, right 30, that gets me over here. Down 30, right 30 is the same as saying 30 over 30, which reduces down to 1 over 1. So my slope works like 1 over 1, down 1, right 1, down 1, right 1, over and over. And now here I get to here, so I actually am exactly at that point. So the ordered pair there is 20, comma, 10. And we can use the same logic on the last ordered pair. What is that one? What? Yeah, that is 15. I don't know what happened to my 1 there, but it's 15, comma, 15. Okay, so from here now, we just take those values, plug them into our objective function, and get our answers. We're looking for a maximum profit, so we're looking for the biggest number that we find. So there's all the work, and what do we get for our answers? 15, comma, 25 gives us what? 140. And 40, comma, 25 gives us what? Is it 225? I don't know. $170? Oh, okay. So 40 comma 25. 3 times 40 is 120. 5 times 25 is 125. So 245. Is that what we said? Okay, 245. Let me double check that 140. That's 45 and 125. It's 170. You're fired. That's all right. 40 comma 10. I get 120 plus 50, so 170 on that one as well. 20 comma 10, that'd be 60 plus 50, so 110. And then 3 times 15 is 45. 5 times 15 is 75. 45 plus 75 is 120. So if we're trying to maximize profit, what are we going to do? Yep, it's this one right here. The max profit is $245, and it happens when we make 40 earrings and 25 necklaces. There's your answer.